Okay, so this is the continuation of firm decision making. So this is part 2. And I want to just highlight something that I noticed a bit later after the last video. I'm trying to do this one. This is many takes later. The marginal cost in the previous graph was actually rounded up based on Google spreadsheets seeming to want to round up to whole numbers. I wish I could default it to 2 decimal places here, but I've corrected that here. And so I want to kind of highlight something from the previous video. So just to go over it, we've got a set of workers. We assume a couple things. They each work 1 hour. We also assume that they are being paid $25 an hour. So our total labor cost is 25 times H, where H is the number of hours. And so we look at what they're paid to get our total cost, and we assume there are no other costs. We then calculated a number of things, and we see how much each worker, the result of how many dolls chairs gets made after we hire each worker. We can calculate something called a marginal product of labor. The word marginal is always going to mean what's the additional, what's the change in something resulting from a change in something else, and in particular, a change in 1 unit. So if we add 1 unit of labor, how much more product do we get? And so if I could see it, I hired Amir, chairs went from 0 to 10, so the marginal product of Amir is 10. If I hire Jonathan is, we see this 25 chairs total made. So the marginal product of Jonathan, or the marginal product of that additional hour of labor, that additional labor unit, is 15. So what I want you to notice is this pattern that Jonathan added more than Amir. So what's the impact of that in our other columns? So let's look at something else here. So this is the average product of labor. You add somebody who's more productive than the previous person, the average goes up. So if the marginal product is larger for the last person hired, the average productivity goes up. And if you think about that, if you hire more productive people, your productivity on average is going to go up. The value marginal product was the price of the chair times how much ever the product was added. So this is what in dollar terms each worker is bringing to the firm. I want to make a note here that as a profit maximizing business, you cannot be paying your workers, generally speaking, more than what they're bringing to the table. You're going to end up losing money. You at least have to make from what they make, you have to be able to sell it and cover their wages, or it's not logical. You're not making as much money as possible. And so going to the marginal cost. The marginal cost is change in total cost. And here again, we are assuming only one kind of cost, which is labor cost. We assume initially that there are some other costs that we know businesses would have. We're just kind of simplifying our world right now to focus on something else. So the marginal cost is, what is it that my cost is going to change by when I add another chair in terms of produce another chair? And I calculated that by looking at my change in total cost. It went from 0 to 25. I produced in the business, 10 chairs were produced. So what did it cost per chair over that range of 0 to 10? It costs $2.50 per chair. So when I kind of talk about the fact that the marginal cost is really ask the question, if I increase my production by 1 chair, how much more will I have in cost, or how will my cost change? I shouldn't say more all the time, because sometimes changes can be negative. But the important thing here is that I am going to make an assumption here about this cost structure. So it's over 10 chairs. I didn't increase. I couldn't, it's like I was going to have to hire this person and have them make 1 chair. There's some assumptions I'm going to make here. And in particular, I'm going to assume that there's some kind of continuous but not constant rate of production. So as Amir is producing, I'm going to plot that each of these 10 chairs does not take exactly the same time. Okay, and we'll talk about that pattern as we come back to the next one. So Jonathan adds 15 chairs, more chairs than Amir, but is paid the same amount. So what happens then? You're paying people the same amount, but one person is more productive than the other. The cost per unit of the chairs is going to go down. So you hire more productive people, the cost of what they make go down. So you see the pattern, the marginal product increases, that reverse happens to marginal cost, it goes down, okay? So you look at what happens to average costs. If the marginal cost is going down, it's dragging down the average costs, okay? If your costs go down when you make additional units for whatever reason, it's dragging down the average cost, which is where you add up all your costs and divide by the Q. And then in this yellow area, and I'll just note that I made the notes here. I'll come back to this. This yellow area we didn't notice is that we've got this declining marginal product of labor. These workers are adding less than the previous workers and continuously so. What does that do? Well, last worker adds less or less productive. Well, it drags down average productivity. Let's go over to our marginal cost. Our marginal cost is going to go up when our marginal product goes down. Cost, if you hire somebody who's not making that much product and you're paying them the same as everybody else, the cost of each unit that you're making is actually more, okay? You see we added $25 to cost, we only added 5 extra units. That's the marginal product of Frederick. So each of those units cost $5 to make, right? Again, increase in cost or change in cost, $25, change in product 5. So each of those over that space. Because we're going to assume some kind of continuous productivity or continuous continuity, but not constant marginal cost. I'll do an example later. We're going to now plot this. And in order to plot it, let me go to Printycam. And I'm going to go to the XY coordinates. I'm going to take out what they have here. I'm going to label the price. Oh, not price, sorry. I'm plotting, note marginal cost. And I'm going to plot it against quantity. So I'm going to put Q. And let's try to be colorful here. Quantity on the horizontal axis. And I'm going to plot the marginal cost. You're going to be real careful here. I had to remake this video after incorrectly plotting. So I want to make sure, I should have said that here's my marginal cost. I have to look at the range of prices. I have to make sure that my my number line has all of these numbers and the highest is 5. So I'm going to just stop at 6 here. And my quantity, I am going from 0, and of course it kind of stops here at 4. It seems like that's some kind of capacity. Should go 10, 20, 30, 40. And I'll stop at 50. I want to calculate now something called the midpoint of Q. So here's my Q. I'm going to insert a column on the left here. So because we are looking at not an increase in cost to do with 1, we don't have Q changing by 1. And in reality, when we hire more people, they don't usually just make one more thing. We're going to plot our marginal. So again, this is a convention. We're going to plot our marginal cost, our cost over this range at the midpoint or the average. So it's going to be whatever my new Q is, my old plus new divided by 2. That's going to be my average. And so I'm using 0 and 10 to calculate my marginal cost over here. Let me try to wrap text here. See if I can form that litany. There we go. Then I can kind of make these a little bit smaller and get everything in. All right, so I'm looking at the per unit cost over range 0 to 10. We're not going to assume that's constant. I'm going to plot it on the graph. So I'm not going to say 0 to 10 range is $2.50 each. We're assuming that the effort or the time it takes going into this is actually going to change as we progress through the workday. We don't work constantly at the same pace throughout the day. And so I'm going to add the two quantities, here we go, that it took to get that marginal cost divided by 2. And I'll do that for everything here. So the average of, or the midpoint of 10 to 25 is 17.5. The average of 25 and 35 is 30. Okay. Just want to make a note now about these colors that I've put. We've made an assumption, I talked about this before, that it's not the individual workers who are different. We're assuming a homogeneous in the labor market, perfectly competitive labor market, that the workers are all the same. It's the order in which they're hired that's going to matter. And so what we can see here is the, okay, let's see here. What we could see here is when we hire Amir, we've got a marginal product. It makes 10 cheers. And we hire Jonathan, then we've got 15 additional cheers. But we want to be careful that is it that Jonathan is just this wonderful hire that we got? And no, actually, what we assume is there's something called returns to specialization. People are different. And when you hire people who are different, they're good at different things, we're going to get a benefit of people doing what they are relatively good at. Relatively good, they have the relatively lower opportunity cost of doing a particular thing. And so when everybody kind of doesn't do every step of the production process, but they do what they are best at, and then the other person hopefully is better at something different, the sum of the parts is greater than the whole. So we call this area return to specialization, where people are focusing doing what they do best. They can do it faster. They can do it in less time. They're more productive at particular tasks. You split up the tasks and give people who are good at a particular thing. That's kind of their field. So what happens, and this can go for a longer time, but just for time's sake, we're going to move on from that. So we're going to have this yellow bit now. What's happening going from hiring Jonathan, who added 15, to hire Christine? She's got less marginal product than Jonathan. And then we hire Frederick, and he's got even less than Christine. So remember, we started out saying that this is something that's happening in a garage, and imagine that you have a limited number of tools. Those things are what we're going to call fixed factors in what we're going to call the short run. So you have a limited space, you have limited tools. When you continuously add a variable factor, meaning we're adding more workers, that can change. We can hire and fire people. But in what we call the short run, there's going to be a fixed factor. There's a limited space that we have access to, and there's limited tools. So we're going to say that we have diminishing returns to that variable input, that we can kind of go up and down at any time, pretty much free to hire and fire in this world. And in this case, the input is labor. We're going to say there's diminishing returns to labor, where if we add more people, and we can actually see this here where we added Mark, we add people. Imagine that you add workers, and let's say it's even a copy machine. You had to wait on the other person if you need to make a copy. And so this is the environment. You've got a set of tools, you've got limited space. And so maybe when we hire Mark, there just isn't even enough space to turn around, and you're kind of messing up some of the production that says people are having accidents. It's just not enough space. And so as you continue to add people to the space and the fixed factors, the tools, people are sitting around, waiting around, they're not doing anything, or they're hampering each other. Okay, so it's diminishing returns, of course, impacts the marginal cost. So now we're going to plot this. Okay, and so over the space 0 to 5, we're going to assume that this marginal cost is an average. It's an average of the costs. The marginal cost, if we had those incremental, what if I increased by 1 chair to going from 1 to 2 and so on. So I'm going to plot 5 against 250. So let's try to do colors here. Let's Let's do my blue. And we got to be real careful. The first time I did this, I totally did not plot it correctly. I have 5 is my quantity, 250 is my marginal cost. Here's 5 is my quantity and 250. Oh, that's supposed to be blue here. At the same time, I want to plot my average cost, which is also 250 here. And I'm going to plot my average cost, though, at my actual number of chairs, my actual queue. So 250. And let's have a different color. My average cost, let's do green. So it's 10 and 250. All right, now I'm going to keep going with my midpoint plotted against the marginal cost. So that's 1750 and 1.65. So 1750, that's about here. And 1.65, a little over 1.5, about 2/3 of the way to 2. Let's just kind of join that. And let's go here. Now 30 to 250. 30 and 250, that's there. My average variable cost, $2.25. 25, here's $2. Let's see here. So I'm going to plot something first. I think I'm okay. So I have 25, $2 to make sure I'm plotting everything correctly. And I'm going to actually talk about something here. This occurred when I did it the first time. For this reason, I'm going to actually do the variable costs first. So let me actually go back. So I'm going to write something. It'll take a little while to kind of practice drawing this. I'm going to make a note of something that I said earlier, and it's about the relationship between average and marginal. All right, so here we are. Let's actually write it there. If the marginal is greater than the average, and I guess I'm going to use the average variable, the average cost. I'm going to define variable cost yet. Then the average costs will rise. So if the last person you hired produces, and I should say we're going between two quantities, if the marginal cost compared to the previous marginal cost goes up, it will drag up the average. If the marginal cost is less than the average cost, whenever you, again, think about the last set of costs you have, so you add something to cost, but it's less than you added to previous costs, and it's going to drag down average cost, and average costs will fall. If the marginal cost is equal to the average cost, then the average won't change. I want to think of this as think of grades in a class. So imagine if everybody in the class took a test, and then there was a class average that was calculated. And what happens is the average actually, if I have the class average except for one student, and if the last student who then takes, say, a makeup exam, if they get more than the class average, then the class average is going to be dragged up by that person. If they get less than the class average is going to go down. If they get exactly the same grade as the rest of the class, then the class average is going to stay the same. And so the reason I'm going to do this now, I drew this before, and I want to be careful not to actually make this mistake again. There's a pattern, therefore, in how the graph is going to look. And I'm going to try to be careful that I'm going to draw the average first and make sure my pattern is going correctly. So here's the quantity. It's going to be, well, we're not going to use 0 because 0, if we're finding the average, it would be our total cost divided by the quantity that we're at, but what is division? Division is repeated subtraction. And the question is, how many times can we repeatedly subtract 0 from our total cost? Where our total cost 0, we could subtract 0 forever. So we're not going to be defining that. We're just going to put a little dash there. All right. So here, got 10 cheers. Our total cost is 25. 25 divided by 10 is 250. So I'm going to plot my 10 cheers against 250. And I'm going to use green for that. Here's my, oops, let's try to keep my colors. Got my Q of 10, I've got 250. Then my 25 against 2. Here's 25 between 20 and 30. And it's against 2. And then I've got an average of 214, and my quantity is 35. Here's 35. Got 214, so hopefully that's kind of looking like that. And then I've got 250 again, matching to 40. And so this is the average cost. Just going to be careful when we draw this. Now I'm going to have my marginal cost in blue. And my marginal cost, I'm going to plot at my midpoint. 5 matches to 250. So here's 5, here's 250. 17.5 to $1.65. 70.5, that's about here, to $1.65, about 2/3 of the way. $2.50 matched to 30. I'm going to be so careful here. There's so many ways to go wrong. There we go here. 250 to our midpoint of 30. Let's go back. So our last is $5 and our midpoint is 37.5. That's about here. And that's to $5. Whoa. All right, so just about here. So I'm going to join this. Please smooth this. Like, so this is a pattern that we talked about before. So we have our marginal costs. Our marginal costs at first, when we're starting out, we just have our first quantity. We don't have a previous marginal cost. What we notice here is our marginal cost of 167. It's below the marginal cost of 250. So going to that 165, the marginal cost, if we join those points, it's falling, it's dragging down the average. Now, interestingly here, so we go to from 165 to 250, the marginal cost is actually increasing over this space, right? But for part of this, it's below the average cost. As long as it's below the average cost, it's going to be dragging it down. At some point, the marginal cost is equal to the average cost. The average is going to stay the same. And then my drawing is not the most beautiful here. So I want to rely on you for a little bit of intuition here. We'll do more examples. Here, this is going to be, and let me actually put it, I'm going to highlight it. This is going to be the minimum of the average cost curve. We're going to come back to that. It's going to be an important point. Beyond that, the marginal cost, if we follow this pattern as we join all our points, assuming some kind of continuous marginal cost function, it's going to drag up the average. So if I draw a little better, this green line should be pretty much kind of going up a little bit there. Okay. And so that's our plot of marginal cost and average cost. And we save that. And I will also get the ship code.